Today we're going to talk about polar arc length and vector definitions. For example 1, find the length of the arc from theta equals 0 to theta equals 2 pi for the curve r equals 2 minus 2 cosine theta. Right here we have a limacin, which means 2 pi will be the entire limacin. We are measuring the length of the entire outer portion of the limacin. Polar arc length looks similar to regular arc length or parametric arc length, but now we're dealing with how to find arc length in terms of polar graphs. So we need an r and we need dr d theta. We have our starting angle of 0 and our upper limit of 2 pi. Let's evaluate dr d theta. That would be positive 2 sine theta. Go ahead and plug that into a calculator. Make sure you're in polar mode and using radians. And we get 16. And here is what that arc looks like graphically. A vector is a quantity having both a direction and a magnitude. The magnitude is the length of the vector. We can denote this as a single bar around v. It looks like absolute value, but it is talking about the norm of the vector or the length of it. The direction is the theta value relative to the positive x-axis. Here we have a vector where the initial point is here and the terminal point is here. Equivalent vectors have the same magnitude and the same direction. They don't have to be in the same location of the coordinate plane, though, to be equivalent. And the component form of a vector is written kind of like a coordinate point, where the first value is the change in x values and the second value is the change in y values. And we use this angle bracket to enclose that. To begin example 2, we're going to graph the vector. The initial point of the vector is negative 1, 3. The terminal point is 2, 7. To graph the vector in standard position, I'm going to translate it down 3 units and right 1 unit. Give the component form of the vector. The component form is change in x's, comma, change in y's. The change in x's is 3 and the change in y's is 4. So we'll do angle bracket 3, comma, 4 angle bracket. To find the magnitude of the vector, we need to find the length from the initial point to the terminal point. That is the length of the hypotenuse of this right triangle we see here. So we just need to use Pythagorean theorem in order to find the magnitude. The magnitude or length of this vector is 5. Find the direction of the vector. That means we need to find theta. To find the angle between the positive x-axis and our vector, we're just going to use trig. We have all 3 sides of this triangle, but I'm going to use opposite over adjacent. So tangent of theta is equal to the opposite side over the adjacent side. Then we're going to take arctan of both sides and plug it into a calculator to evaluate. And that would be 0.927 radians. In example 3, we're going to find the direction of the vector given in component form negative 3, 5. The vector negative 3, 5 would have an initial point at 0, 0 and a terminal point at negative 3, 5. The angle we need to solve for is here. I've been given the change in x and the change in y, so I'm going to use tangent of theta equals y over x. Here's the problem though. Arctan only goes from negative pi halves to positive pi halves, and this angle is clearly out of the range for arctan. The theta value that the calculator gives me is negative 1.030376827, etc. But I know that's a negative angle that is between the numbers 0 and negative pi halves, and therefore that angle is in the 4th quadrant. So I'm actually getting this value of theta right here. Let's call this angle alpha. So alpha is equal to negative 1.03, etc. But how would we find theta? Theta is equal to alpha plus pi. We need to add pi radians in the counterclockwise direction in order to get the value of theta. Once we do that, we get 2.111215827, etc. That rounds or truncates to 2.111. For example 4, if the magnitude of a vector is 6 and its direction is 2 pi thirds, write the vector in component form. I'm going to graph that real quick. So our angle is 2 pi thirds, and the length from the initial point to the terminal point is 6. Could consider 6 as our radius and 2 pi thirds as our angle. Remember, we have some relationships between x and r cosine theta, as well as y with r sine theta. As we said before, r is the same as our magnitude. Now plug it in. The component form of this vector would be negative 3, 3 root 3.